Hi guys, so for my section I'm supposed to teach on is just about the renal clearance. And the renal clearance, it's pretty pretty clear and self-explanatory, but the kidneys in general are kind of a difficult thing to learn about. I'm talking about the nephron and all the different functions of it. So if after this, if you're still kind of confused or hesitant about renal clearance and what it means and what it does, the video that I have attached to my portion is really good at explaining the renal clearance, so I would also check that out. But I'm just going to go through my notes on this stuff, and hopefully that it will help you to be able to understand renal clearance a little bit better. So first of all, clearance, the definition of it is just says right there, it's the measurement that compares the rate that a substance is filtered with a rate at which the kidneys excrete the substance in urine. So it's substance that is filtered and substance that is excreted. And so the renal clearance is just the volume of plasma that is completely cleared of a specific compound per unit of time that is measured as a test of kidney function. So that's more of the renal clearance part. And the units for renal clearance is in millimeters of plasma per minute. And this represents the volume of plasma that is completely cleared of a particular substance per minute, like I just said. So an example is, say, 100 milliliters of water enters the kidneys and the kidney tubules, and all of the water is reabsorbed, but none of the particular solute is reabsorbed. So the renal clearance would be 100 milliliters per minute. And another example, say the same thing, 100 milliliters of water was entered the kidney tubules, and only 50 milliliters was reabsorbed. The renal clearance would be 50 milliliters per minute, because half of the filtered plasma is cleared of solute, but just half of it. So each substance that is filtered in the kidney tubules has a specific clearance volume. The volume is a function of glomerular filtration, reabsorption, and secretion, and sometimes secretion. So just remember, it's glomerular filtration, reabsorption, and sometimes secretion. The difference between filtration and excretion allows us to see how the nephron is handling a particular substance in the tubules of filtration, reabsorption, and secretion. So it helps us to be able to know how the kidneys are working and what substances may not be being absorbed or reabsorbed or secreted correctly. The renal clearance is measured by collecting urine over a given time and comparing the concentration of a given substance found in the urine with concentration of the same substance found in the blood. The relationship for the given substance, there's a formula right here, and the substance will be resembled as X. So there's Cx equals Ux multiplied by V divided by Px. And what each of those stands for, Cx is the clearance, the Ux is concentration of X, which is a substance in urine, and V is the urine flow rate. And then, and you can get the urine flow rate by dividing the volume by the time. And then Px is plasma concentration of X. So basically how you get the clearance is you multiply the concentration of the substance in urine by the urine flow rate, and then you just divide that by the plasma concentration of the substance, so the blood, substance in the blood. An example is the substance in urine is measured at concentrations of 100 milligrams per milliliter. The urine flow rate is 1 milliliter per minute, so the clearance would be 100 milliliters per minute, meaning that 100 milliliters of plasma are cleared of this substance per minute. So hopefully that helps make some more sense of that formula. So also, the clearance equation can also help to determine glomerular filtration rate, so that's the GFR, but it will only do that by strict criteria, and the two strict criteria of being able to do that is, number one, the substance must be small and non-charged, so meaning that the substance must be freely filtered at the glomerulus with no impediment by negatively charged membranes or the pore size of the filtration barrier. So that's one of the criteria. The second one is just the health of the kidney, just knowing the creatine value of 65 per minute. So saying if the creatinine value of 65 milliliters per minute in the kidney, but normally it's supposed to be 88 to 137, then you could determine that the GFR is compromised. And it's easier in a clinical setting because the production rate of creatinine is constant. Blood creatine levels will remain constant as long as the kidney is functioning properly. So if levels of this in the blood begin to increase, it is a sign that the kidneys are beginning to fail, which is not good. So just being able to test that can really help you know the health of the kidneys. So renal clearance is important, and knowing and understanding our kidneys and what substances can be filtered through and helpfully the rate of the substances being able to do that. So hopefully that helps, and yeah, watch the video that I also have attached. It will, I think, help explain renal clearance a little further. So thanks.